Good evening, my dear students and my dear friends. So there is a technical problem for streamlining, okay, due to technical internet problem. Now we are rectified that. I think, so what is the 10 minutes you are lost, that you no need to worry, we will be continuing the 10 minutes extra for the class today, okay. So just be patient. So this is not due to ourselves, it is due to the technical problem, that is internet problem, okay, it has been rectified, okay. So I will start with the class. As we discussed about today's class is going to be the enzyme catalysis, because enzyme catalysis, when we are talking about, you know that it requires certain activation. That's what today class is also required little activation energy. That's why it has delayed. I think now the catalyst is working fine, and now we can talk about the enzyme catalysis. So before getting into the enzyme catalysis of today's topic, I will be talking about the recap for the yesterday's class, that is last week class, which I did on the surface chemistry. In the last week we have discussed about the basic chemical adsorption theory, in which, so we are going to talk about the mechanism of catalysis. Next we discussed about the promoters. We discussed about the poisoning of catalyst. We discussed about the characteristics of a catalyst. We discussed about several characteristics of the catalyst, because we have so many chemical substances in the nature, but we cannot consider all the substances as catalyst. So that's why we have chosen certain characteristics. The first and foremost character is, you all of you know that it should exhibit the variable oxidation state, it should have active centers, it should possess a large surface area. So these are the major criteria, and apart from that, it should not physically or chemically change its composition. So these are all the criteria which we are looked at, and the one of the important characteristic of a catalyst is it is very selective and regospecific. That means it is the stereoselective product will be obtained, and each catalyst is only specific for a particular type of reaction, with certain examples we have discussed in the last class. So today class I will be talking about the enzyme catalysis. Enzyme catalysis is a basic catalysis, you all of you know that, which occurs in the plant. But before getting into the actual today's class, let me talk about last class, which I gave a 10 question in CPP. So majority of the student misunderstood the concept of the catalysis which I discussed with the topic. So this question is purely given to understand how actually the equilibrium constant is affected by the rate of the reaction. We all of you know that, but whether the catalyst is does the same thing, that's what we asked the question. So keeping that point of view, the question goes like this: which of the following is not true for a catalytic reaction? The option, when you look at, so when we look at the characteristic of a catalyst, we discussed that the rate of forward reaction and the rate of backward reaction is always kept constant. That's why we get equilibrium. So now if we talk about equilibrium constant, means their rate of forward, that is velocity of forward reaction, and velocity of backward reaction is same. Now the equilibrium constant is only affected by temperature and the concentration of the reactants. It is not affected by the catalyst, because catalyst is just a transporter which transports the reactant to the surface and converts into activated complex format, and then finally converts into product. So it just acts as a transporter, it does not alter the rate of a reaction. The rate of the reaction is altered only by the temperature. Then your option should be B. So now I think you got the concept right, and you look for these kind of problems when you find for answering. That means, remember, the catalyst is not going to alter the equilibrium constant. Only the temperature alters equilibrium constant. The rate constant is purely depends upon temperature. Now, so we will be talking about today the adsorption theory, that is the mechanism of catalysis for the chemical adsorption process, and basically we will be talking about enzyme catalysis, which is the third part of the catalysis, and we will be talking about the mechanism of enzyme catalysis, how it happens. So then we will be talking about certain characteristics of enzyme catalysis. and later we will discuss about what is the difference between enzyme catalysis as well as the chemical catalysis, and lastly we will be talking about the applications of this catalyst and the catalysis process, which is the part of your surface chemistry. So now when I talk about the adsorption theory, so basically the mechanism of catalysis explains in different theories, but basically we talk about adsorption theory. The adsorption theory talks about basically the reaction between the two gases catalyzed by the solid. It may be homogeneous or it may be heterogeneous, but it is always goes with the contact process. That's what we call as the heterogeneous catalysis, also contact catalysis. The catalyst functions by the adsorption of the reacting molecule on its surface. So now this point is very important here. So now I am not going to read out all these things, just you glance these points. So adsorption theory is as much as same as the intermediate compound theory, which we talk about in the chemical kinetics. And the intermediate compound or the activated complex which is formed on the surface of the catalyst will be held feebly or with van der Waals forces. Sometimes it is also held with tightly with the chemical bonds. So if it is held tightly with the chemical bond, then the bond has to be broken down and the product has to be dislodged from the surface of the catalyst or active centers, and then it should be completely removed from the active center, so that it facilitates for the further reactant to come and get adsorbed for the chemical adsorption process. So that's why, so when you talk about the enzyme catalysis, so this catalysis basically talks with respect to so many factors. So enzyme catalysis, the first factor which I am talking about is the discovery or introduction. So when we talk about this enzyme catalysis, there are numerous organic reactions taking place in the body of animals or in the plants, maintains the life process. These reactions being shown are remarkably catalyzed by certain organic compounds called as the proteins. So these proteins, finally called as the enzymes, these enzymes are protein molecules which acts as biocatalyst to speed up the organic reactions in living cells. The catalysis brought about enzyme is known as the enzyme catalysis. Each enzyme is produced in a particular living cell where the catalysis takes place. The many enzymes have been identified and obtained in pure crystalline state from the cells to which they belong. The unit enzyme was prepared in the laboratory in 1969. So before that, the first person, that is a French chemist, Anselme Peyman, in 1833, he is the first person to identify the enzyme catalysis process. So now if we talk about these enzymes, so there are many enzymes which are used in the biological system. One such example which I am going to talk about is the yeast is a bacteria which you all of you know, so which contains the two enzymes, which is basically used for the conversion of the cane sugar into the ethanol molecule. So now if you are talking about the cane sugar, you all of you know that the C12H22O11, so which undergoes hydrolysis with the help of the first enzyme invertase. So this invertase makes the two components out of this disaccharide into monosaccharides. One is the glucose and another is the fructose. This is the glucose is all of you know that it is called as aldohexoses and the fructose is called as aldoketosis, whereas the glucose contain aldehyde group, whereas the fructose contain the ketone group in the molecule. Second part of the bacteria, that is the another enzyme called as the zymase, which converts the each glucose or fructose molecule into the ethanol molecule. So along with the carbon dioxide plus the quantity of heat will be liberated in the process. Next, if I talk about the another process, so which is called as hydrolysis of sugar, that is usually done by a process called as urease. Urease is an enzyme which makes the molecule to undergo breakdown to form ammonia and carbon dioxide. I think you all of you know the structure of urea. Urea is nothing but C double bond O NH2 NH2. So this is the urea when it undergoes hydrolysis. So and in presence of urease, an enzyme, this gets converted into 2 ammonia molecule plus carbon dioxide. Now you hope, so if this urease does not function in the biological system, you think of the kidney failure, because the accumulation of ammonia molecule in the kidney takes place and finally it enters to the blood. Blood nitrogen level rises and automatically it causes the kidney failure, and finally the people may get into coma state. So that's why imagine the urease is an enzyme which breaks down this urea into ammonia. Later, so when we talk about the catalysis enzyme process, before getting into enzyme catalysis process, we will discuss how actually the classification of enzyme catalysis happens. So there are 6 class of enzyme catalysis has been classified. So basically the first one is called as oxidoreductases. The first one is oxidoreductases. The moment if I talk about oxidoreductases, it means these are the enzymes which are specific for only oxidation and reduction. So there will be a simultaneous oxidation and reduction will be carried out by these enzymes. If I talk about the second type of enzymes, that is called as transferases. So these are very specific enzymes which are going to transfer the certain functional groups during the catabolism process. So that's why these are all called as transferases. If I go for the third type of enzymes which are called as hydrolysis. So they do basically hydrolysis process in the biological system. The fourth type of enzyme which we called as lyases, okay, which bring down the process without using hydrolysis or oxidation process. So that's why these are all called as lyases. The fifth type of enzyme which comes under isomerases. So these isomerases are very specific. They take particular kind of component, that is D and L tartaric acid. If it is in the mixture, we can separate them into an individual component. So it specifically picks one kind of isomers. That's why they are called as isomerase enzymes. The last and the sixth type of enzymes which is called as ligases, which are nothing but called as a binding agents, which links or joins different products in the mechanism of enzyme catalyzed process in the cell. So each enzymes which are produced in the cell are very specific and they are very small amount. How actually they bring about the process, so that is what we will discuss with the pictorial notation. So when we talk about the mechanism of enzyme catalysis, so this goes back to year 1913. This concept was proposed by the Mental equation. So this is also called as the lock and key mechanism. So when we talk about the MM equation, okay, the Mental equation, which is nothing called, generally called as MM equation, where we talk about the E, which is nothing but your enzyme, and the substrate, which is where actually in chemical kinetics we call it as a reactant, here we call it as a substrate. When they combine together, okay, they form a ES complex, that is enzyme substrate complex. So in chemical kinetics we talk with respect to the adsorb or what we call as activated complex. After adsorption there is a formation of activated complex takes place. So that is what here also there is enzyme substrate complex formation takes place, which brings about so many conformational changes within the molecule, and finally it undergoes for a catalysis process and it forms a enzyme product complex. So later, so this product dislodges from the enzyme. So this is the entire process which is similar to your catalysis which we had discussed in the earlier catalysis, which is called as the chemical catalysis. There also the first process, what it happens, it brings the reactants to the surface of catalyst. Second point, after bringing the reactant to this, so the entropy reduces, thereby molecules gets adsorbed onto the surface of active center. Third one, there is a formation of activated complex takes place. Once this activated complex takes place, it loses its energy and gets converted into product. Once the product is formed, the next step is dislodge of the product from the active centers takes place, and finally the removal of this material from the surface takes place, or from the near to the active centers takes place, so that it makes a space for the incoming reactant molecule to come and adsorb, and the process keeps continuing. So here also, when you look at in this equation also, equation also, what he proposes is the enzyme and substrate comes together, and thereby you are going to get enzyme substrate complex. This forms the activated complex, which is nothing but enzyme product complex. So later the product gets separated and enzyme will be active state once again, so that it will further do the process of catalysis. So now when we talk about how actually this process of catalysis goes with respect to. So now when we talk about enzyme catalysis, here also there are a lot of chemical reactions which are brought by the enzyme. So because enzyme is having a three-dimensional activity center, so these activity centers bring down the substrate together and makes the process of conversion of product. Once the product formation takes place, so there the conformational changes of the earlier reactant happens by breaking the old bonds and making the new bonds. So which facilitates the product to come out from the surface of active centers. Once the active centers are get free, the product is left free, so that the next incoming molecule makes this equation. So how actually this Michael-Mantes equation gave, that is, he gives a mathematical equation, so where he consider the velocity of the reaction with respect to the d of the product with respect to t. So this is what we talked with respect to in earlier case of catalysis, that is dC by dt. So where there also we talk about concentration, here also we talk about the concentration of your substrate. So then finally he derives the equation, because that derivation is not there for you people. That's the reason we are directly taking the equation of equation, that is Michael-Mantes equation. So where he says the velocity or the catalysis of enzyme catalysis, the maximum velocity, which is equal to the substrate concentration over the Km, which is a constant with respect to concentration of substance. So now this substrate plays a very important role, as the substrate is able to bind to the particular enzymes. So this is also called as the lock and key model, because the particular lock, how it uses a particular key to open. Similarly here the enzyme catalysis also very specific and particular. So now when we talk about this law, the particular substrate, which is I called as a key, this is I called as a lock, when they get in exactly, then they open the system. Similarly here also the product is going to be formed. So now with respect to this, before getting into the actual the characteristic of biocatalysis, so I will tell you one important thing which you are all waiting, that is what the contest time. So now I have given one important point in this class. So based on that, we are going to have the contest time question. Now the contest time question goes like this: on which factor the activity of the catalyst depends? Okay. understood what I have given in the contest thing, I think your answer for that. Okay. So now we will start with the today's topic, that is the characteristics of enzyme catalysis. So now, as similar to your chemical catalysis which we have discussed in the earlier classes, the enzymes are the most efficient catalyst. So how to define this and how to prove this? That is why I have taken one example. There is one molecule of an enzyme may transfer 1 million molecules of the substrate, that is reactant, per minute. That is what you will think of the hydrogen peroxide which is produced in the biological system. If you leave that as such, so that will damage the DNA. So that is why what will happen is the zinc anhydrase is one enzyme which is present in the biological system, which converts about, that is water plus a nascent oxygen. This happens just in 1 minute. Per minute it will convert 10 power 6 molecules of hydrogen peroxide into water and nascent oxygen. Now if I write this chemical reaction, if we want to bring about the same process in without biological system, that means by using a catalyst. So this normally goes by using a platinum catalyst in chemical catalysis. If I want to do the process of the conversion of, that is what we are talking about, is hydrogen peroxide decomposition takes place to form water plus nascent oxygen. So this requires high energy. That is the first thing is, so it requires roughly about 18 calories. Okay, so that is a huge amount of energy it requires. So if I use a method where the activated platinum, if I use, then I can bring about the activation energy to about 11 calories per gram. If I use the enzymes, then automatically the energy of activation energy required for this process will bring down to 2 calories. So now you can see how much energy is reduced at the same time. So you can see millions of compounds can be converted immediately without any problem. So this is what happens in biological system. If hydrogen peroxide is left as such in the electron transport chain, so this creates a lot of problem for the DNA. So that's the reason the zinc anhydrase, which enzyme which is present in the biological system, will convert this entire molecule into water which is less harmful. So that is why we are talking about the enzymes are most efficient catalyst than the chemical catalyst which we use. Next is the enzymes catalysis is marked by absolute specificity. That is where I am using the word absolute specificity. Whereas in the case of chemical adsorption or chemical catalysis, we have discussed about just specificity. But in this case, I will be talking about absolute specificity. What this talks about? Basically, if I take an example of urea, so which is NH2, NH2. I will write one more structure, I think you will understand this. So this is amide structure, I am going to write NHCH3 with NH2. So now these are the two components, organic compounds. Now if I want to make the hydrolysis process by using the enzyme called as urease, it undergoes hydrolysis. Here also I am using urease in hydrolysis process. Now in this case, the first case, you can expect the product to form as ammonia and you get carbon dioxide. Whereas in the second condition, the reaction does not occur. That is what enzymes are very specific to substrate. Here you can see here the molecules are, that is methyl urea. If I am taking, it is just H is replaced by the CH3 molecule. So then automatically it cannot fit into the enzyme. Thereby the conversion of the urea into ammonia happens only by using urease enzyme. If I use urease enzyme for methyl urea, it does not do the process. Hence enzymes are absolutely specific in nature. So without that we cannot get the proper reactions. So coming to the next type of property of this enzyme is the rate of enzyme catalyzed reactions is maximum at the optimum temperature and also at optimum pH. So when I talk about optimum temperature. This is what is very, very, very important. So we all know that. So whenever the rate of a reaction is taken with respect to the temperature, especially for the enzyme catalysis, initially as the temperature increases, the rate of the reaction also increases and it becomes maximum, later it falls down. So this is where we call as the maximum efficiency of the enzyme. Our enzymes are effective at a particular temperature. So now you can see at this particular temperature, enzyme shows the maximum activity, and below which enzyme does not show activity. They show activity but not the optimum, whereas above the temperature also they show the activity but in the decreasing order. So now this indicates, so there is very, very specific for the temperature. So that's why usually all enzymes, the bioenzymes which works at 35 degrees to 37 degrees maximum. So that means below this 35 degrees the activity of the enzyme is less, and above 37 the activity is less, because as the temperature rises, the three-dimensional structure of these enzymes will lose and the biologic activity destroys. So thereby enzymes are active only at particular temperature, so that is from 35 to 37. The best example I can give you with this is, because whenever we get a fever, the body temperature rises, thereby the enzymes present in the body does not activate by themselves and they won't work effectively. Thereby during that process we find the what we call as uneasiness, and we don't feel to eat the food because the catalysts are not active. Automatically the process of biocatalysis does not occur until unless the body temperature comes back to normal. So that's why that is also one example which we can tell the enzymes will work only with optimum temperature. So the next thing which I am going to talk about is enzyme catalyzed reactions works at maximum pH. So this is what is very, very, very important, because now the question comes with optimum pH. Now if I take certain enzymes which is saliva which is present in the mouth, this is just emulsifying agent which is present in the mouth. Now so when this emulsifies, so this food will get emulsified and easily can get into your stomach. In the stomach you find the HCl. The HCl is secreted where we have two types of enzyme. One is called as proteases, that is called as pepsin and renin. These are the two enzymes which are active only in acidic pH. So thereby it breaks down the protein there. So the next step, when it goes to the bilirubin will be secreted, where we get the saponification process happens for the oil, the material which we are consumed. That means the fatty food which we are consumed, so which will be catalyzed by the bilirubin. So now these enzymes are very, very, very important. Now if you look at the pepsin and renin, they are active only in acidic pH. That means when you talk about the bilirubin, that is acts in the basic pH. So the renin does not work in the basic pH and the bilirubin does not work in acidic pH. So enzymes are very, very, very specific and they work maximum at a particular pH. So this is very, very important. And if you look at so many examples like this in the biological system, even the urease which works in the basic media. The next point which you are talking about is enzymes are markedly inhibited or poisoned by the process. So as similar to earlier when we had discussed about the catalysis which we had discussed with respect to chemical catalysis, there also we find the activities are get poisoned. So here also the same phenomena occurs. The catalytic activity of an enzyme is often reduced, which is in biological system we call it as inhibited or completely destroyed or poisoned by the addition of other substances. These inhibitors or the poisons interact with the active or functional groups of the catalyst or on the enzyme surface, and they bring down the activity of that, and they can be a strong bonding with that. So heavy metal ions like silver, mercury, they react with the thiol groups of the enzymes and poison it. The best example how it happens is, suppose an enzyme which is bonded with the SH group, that is thiol group. When it comes in contact with the Ag plus, automatically, so there is a formation of enzyme sulfide plus Ag, whereas the H plus is given out. So now this complex, what is formed here, it is irreversible complex. So thereby it is going to be the poisoning the activity. Now the physiological activity of the many drugs is related to this action of enzyme inhibitors in the body, especially the sulfur drugs, the penicillium and the streptomycin inhibit the action of several bacteria which will bring about the biological activities which are effectively used for curing pneumonia, cholera and many other infections. The last point of your catalytic process of enzyme catalysis is the catalytic activity of enzyme is greatly enhanced by the presence of activators or coenzymes. So this is once again, it is similar to the chemical catalysis which we have discussed. There also we add a certain chemical substances which are not the catalyst, but they bring about the efficiency of the catalyst in a better way, that they are called as the promoters. But in this case also, in the biocatalysis also, certain co-activators or coenzymes which makes the process of catalysis will be done with the activators or coenzyme. So now those coenzymes or coactivators sometimes are your vitamins. Especially majority of enzymes work with respect to certain process of the vitamins and they bring about the activation of your catalyst, and the active centers are kept active for the bioenzymes or the proteins. So those substances are called as the coenzymes or the co-activators. The best example, I think you might have heard of a disease called as stroke. Whenever a stroke occurs, there are a lot of pathology process which occurs in the biological system of the central nervous system, in the blood vessel or in the what we call as vascular system. So there is a pathway called as a methionine pathway occurs. So in this methionine pathway, so there is a conversion of methionine to homocysteine. So when we talk about this conversion of homocysteine, so there involves the two process of these coenzymes or activators, that is called as one is the vitamin B6 and the vitamin B12 is essential in the process. So when these enzymes lacks, automatically or these cofactors lacks, the enzyme activity comes down. What are the enzymes which are present in this pathway are, one is called as CBS enzyme, that is called as cystothionein beta synthase, and another is called as MTHFR, methyl tetrahydrofolate reductase enzyme. That means it brings about oxidation reaction. Why I am talking about the reductase process is the methionine is a one amino acid in the biological system, so which is essential amino acid which is having a SH group, where I discussed in the earlier property where which is get poisoned. Once this get poisoned, so automatically the methylation process in the biological system does not support. That means it does not go with the cascades of reaction. So in order to make this process effective, so we are going to supplement vitamin B6 as well as the vitamin B12 to make these two enzymes active, so that the process of methylation happens continuously and that does not bring about any genetic mutations and makes the enzymes to work effectively and makes not to the person should not get into any disease conditions, especially like stroke is the one example. So these are the two cofactors, the vitamin B6 and B12, which comes in that process. Apart from that, these what we called as this process are also affected by a non-small what we call as a non-protein materials, which is purely organic compounds, which I already said as coenzymes. So they are very, very important. That is, one is the ubiquitin, that is also very important enzymes. So now the applications of catalytic process and catalysis process and its application. So when I talk about some of the industrial applications, we discussed like this: the synthesis of ammonia from nitrogen and hydrogen. So when we talk about this, so this all of you know that this is the one of the best process for manufacturing of urea. Ammonia. This ammonia is very important compound in industrially important compound. The reason is the fertilizers. All nitrogenous basis compound acts as a best fertilizers. So this ammonia is one of the important compound for any of the fertilizers. So this is works with the Haber's process. When we talk about this Haber's process, here the basically iron acts as a catalyst in presence of molybdenum as the promoter. Next is the catalytic reforming of naphtha. This is what we use in the production of gasoline. So this is a petrochemical industrial application. So where the production of high octane gasoline, which is to be obtained only by the catalytic reforming. The reforming is a process where the conversion of or increasing the octane number of any fuel. Suppose I have a structure like a linear molecule. Example, I can take it as CH3, CH2, 5 times CH3. Now you can see this molecule, what I have written is the N-heptane. The moment if I write it is an N-heptane, so you know that this is one of the petroleum byproduct. Now the petroleum which we are using as a gasoline is called as 2,2,4 trimethyl pentane. So this is the IUPAC name of your petrol, which is also called as isooctane, which is very similar to your N-heptane. Now if I use N-heptane, there is a problem for the engine. Apart from that, the unburnt carbon dioxide and carbon monoxide will be as exhaust, which will be given to the environment and which will cause environmental pollution. So thereby, in order to make this carbon dioxide less and carbon monoxide also less, so we are going to make use of the catalytic reforming of naphtha. So where we get high octane fuel, which is the gasoline. So thereby environmental problem can be solved by this process. The next process which we are talking about, biomimetic industrial catalyst. So this is nothing but limiting the enzymes to produce aptically active stereoisomers. So you know that the drugs today what we are using are very specific. That means D configuration and L configuration. So L configuration does not work for some diseases. For some diseases the D configuration only works. So the best example I can give is the D glucose and L glucose. The L glucose is not digested or the metabolized in the biological system, only the D glucose is metabolized. Okay. So like that, so if you want to get a particular selective of isomers, so this catalysis plays a very important role. That too biocatalysis plays a very important role. Next is expensive, but it is biometallic catalysis. So now the question comes, what is this I am talking about? So this biomimetic industrial catalysis very expensive, but it is very specific. So that is what I want to convey. Next is the production of environment. That's what we can think of n number of process which we talk about. For best example which I am talking about is the polymer degradation, because the polymers which we are using, the plastics which we are using, they are not biodegradable. So now the future material which we are looking for is PHBV, which is one of the polymer which is biodegradable and by using the microbes. So thereby the problem and the management of the plastic can be made easily when compared to normal catalysis process. Normal catalysis process means what we have to do, we have to collect the plastic, we have to incinerate in presence of some metals so that we can reduce the carbon dioxide and carbon monoxide and the oxides of nitrogen, phosphorus if they are present in those substances, which is very tedious process. But when we use this biocatalysis, the protection of the environment can be done easily. So that is the best application of this biocatalysis or enzyme catalysis. Next is we will be talking about immobilized enzyme as industrial catalyst. That means the fructose is a sweetener and is a choice. So where we can use certain other materials like the adulteration of food which we are carrying out today. So that is all very dangerous to the biological system, which bring about the activity of the catalyst reduced. Next is the catalytic cracking, which is also once again the very important role in petrochemical industry, because when we take the crude oil which contains n number of hydrocarbons which cannot be used as a fuel. So now we can go for the breaking down those heavy or long chain hydrocarbons into short chain hydrocarbon by a process of cracking. So cracking is basically the breaking down high molecular weight hydrocarbon into low molecular weight hydrocarbon with the help of certain catalyst, especially where we use Al2O3 with silicon as a mixture of catalyst. So this aluminum silicate plays a very important role in bringing about the catalysis process. So now with respect to this, so I would like to announce the last class, the winners of contest time. The yesterday's class contest winner was Mr. Hemant. Congratulations Mr. Hemant. And now before concluding my class today, what we have done, so we have discussed about the chemical catalysis and its mechanism, and we discussed about the mechanism of catalysis of adsorption, how actually the different process takes place on the surface. Then we discussed about what is enzyme catalysis, why the enzyme catalysis is important, and what is the mechanism of enzyme catalysis, and how the mechanism is brought and it is studied by using equation, that is nothing but Mantle-Michael equation. So then the third point which we have discussed about today related to enzyme catalysis is the characteristics of enzyme catalysis. It works at better at optimum temperature, optimum pH, it is absolutely specific, and it brings about the reaction in a huge way with the small quantities, and we have discussed about the N applications of the surface chemistry as well as the adsorption and the chemical catalysis and enzyme catalysis. So my dear friends, now I made the 10 important questions based on today's topic what we have discussed on enzyme catalysis. So that goes for your that is class practice pack. What are the topics which I covered, based on that I had chosen 10 important questions. Now if you are not understood some of the concepts, please go through the video once again, and right now please take up the CPP class practice text immediately and find out the right answer for all your questions and get the right answer for them, and all the best.